Hello students, today we're going to learn about finding the probability of mutually exclusive events or non-mutually exclusive events. Here's an example of things that are mutually exclusive. Let's say that you've got students at Butler High School and Independence High School, and you randomly choose a student. You would agree they would either be from Butler or Independence, but there's no way they could be both from Butler and Independence. So those would be what we would call mutually exclusive. They can't be both. It's either one or the other. However, let's say you've got students from Butler and Independence and you choose one that's from Butler or a sophomore. Now, I think you would agree that Butler has sophomores and Independence also has sophomores. So the fact that you've picked one from Butler could include sophomores from Butler, or they could be from Independence. And so those two, there's an overlap. There are sophomores in both Butler and Independence High School, and that's why those would be not mutually exclusive. But let's look at a couple examples from your notes. Here you've got a jar containing 5 blue marbles numbered 1 to 5. The jar also contains 5 red marbles numbered 1 to 5. And you close your eyes and you randomly pick a marble. It is red or it has a number greater than 4. So is that mutually exclusive or not? All right, so you've got red marbles or a number greater than 4. Well, would all marbles greater than 4 just be blue? No, there could also be some that are red, right? So these are not mutually exclusive. All right, let's look at number 2. A basket contains 3 apples, 4 peaches, and 3 pears. You randomly select a piece of fruit. It is an apple or it's a peach. So you want to ask yourself, is there a way it could be both an apple and a peach? And the answer, of course, is no. So these are, yes, these are mutually exclusive. It's one or the other. And in example 1, there is a way that it could be both red and a number greater than 4. So that's why they are not mutually exclusive. All right, so let's find the probability. Before we begin on that, I'd like you to make a note that the word or in these probability situations means addition. Yesterday we dealt with the word and that implies we multiply to find the probability. Whenever you see the word or it's implied, you will add. So for instance, you've got a basket of 5 apples, 5 peaches, 3 pears. You randomly select a piece of fruit. It is an apple or a peach. So first of all, decide, is this mutually exclusive? Is there a way you could have an apple that's also a peach? No, that would be silly. So, all right, first of all, how many ways are there getting an apple? Well, it's 5 out of 13 different pieces of fruit. Plus, or, how many ways are there getting a peach? Well, there's 5 ways out of 13 of getting a peach also. So you add those together, and the probability of getting one or the other is 10 over 13. Now, number 4, we've got a box containing 6 red playing cards numbered 1 to 6. The box also contains 4 black playing cards numbered 1 to 4. You randomly pick a playing card. It is red or it has a number less than 3. Okay, so ask yourself, is it possible to have a card that's red and it's also less than 3? And the answer is yes. So these are not mutually exclusive, so we handle these a little bit differently. First of all, deal with the probability that it's red. Well, that's 6 ways of getting a red out of a total of 10 playing cards. Or, how many ways are there of getting a number less than 3? So that means it's either number 1 or 2. So you could get a number 1 or 2 from the red cards, or a number 1 or 2 from the black cards. So that's a total of 4. So there's 4 ways out of 10 of getting a number less than 3. But we need now to pull out the ways that they're less than 3 that are also red, because you can't double count. So there are 2 ways of getting both red and less than 3. So we have to subtract those out. So what we've got here really is 6/10 take away 2/10, because 4 minus 2 is 2, 6/10 plus 2/10, because 4 minus 2 is 2. And so that will be 8/10, or reducing that by 2, you get 4/5. And that's the probability for number 4. All right, example number 5. We've got a magazine that contains 12 pages. You open it just at random to a certain page, and the page number you land on is either 6 or 11. So ask yourself, is there a way it could be both 6 and 11? No, it's either one or the other, so this is adding. How many ways are there of getting a 6? Well, it's 1 out of 12 pages, or plus. How many ways of getting an 11? Well, again, it's 1 out of 12. So in other words, that's 2 out of 12, or reducing that fraction, there's a 1 out of 6 way of getting one or the other. Now, number 6, we've got a bag containing 6 yellow tickets numbered 1 to 6. Bag contains 6 green tickets numbered 1 to 6. Now you randomly pick a ticket. It is green or it has an odd number. So is there a way to get it both, a green and an odd number? Yes. So these are not mutually exclusive, so we're going to have to subtract something away. But let's first deal with the green. How many ways are there of getting a green? Well, it looks like it's 6 out of a total of 12 tickets. Or, how many ways are there of getting an odd number? Well, you've got 1, 3, and 5, and you've got that for both the yellow and the green. So that's 1, 3, or 5 for yellow, 1, 3, or 5 for green, so that's a total of 6. But then we need to subtract out of it the odds that are also green, because you cannot double count, so that would be pulling away 3 of them. And let's see, so we've got 6 over 12 plus, subtracting that out, that'd be 3 over 12 would be 9 over 12. And that reduces by 3, so you'd have a probability of 3/4. Okay, over to number 7. There are 11 shirts in your closet, 4 blue, 7 green. 1 of the blue shirts and 5 of the green shirts fit well. The others are too big. I guess you lost weight. That's good, unless you're sick. You randomly select a shirt to wear. It is green or it fits well. So again, is there a way to get both? Are there some green ones that also fit well? And yeah, in fact, 5 of them. So we're going to have to subtract those out when we're all done. So first of all, how many ways are there of getting a green shirt? It looks like 7 out of 11. Plus, how many ways are there of getting a shirt that fits well? Well, it's 1 of the blue and 5 of the green. So that's going to be a total of 6. And then we subtract out of it the green shirts that also fit well, so we don't double count, and that's 5 of them. So in other words, it's 7 over 11 plus 1 over 11, which becomes 8 over 11. Okay, Now, in numbers 8 and 9, you're now being exposed to some probability notation. P of A means the probability of A is 3 over 10. The probability of event B is 11 over 20. So what's the probability of A or B happening? Well, or means add. So we're going to take 3/10 plus 11/20. Now, I remember back from doing fractions by hand that 20 is the common denominator for both. And so 10 became a 20 by multiplied by 2, so that 3 gets multiplied by 2. And so we have 6/20 plus 11/20, and that gives us 17/20 of a probability. Now, in number 9, we've got that the probability of event B is 3 over 5. The probability of A or B is 4 over 5. Well, what was the probability of A? Okay, so here we're having to solve for A. So we've got that event A plus, well, I guess we can do it this way, the probability of event A plus the probability of event B, which was 3/5, equals probability of A or B. And that the or is why I put the plus sign there. So how are we going to solve for probability of A? Well, I hope you'll see that we just subtract 3/5 from both sides. 4/5 minus 3/5 is 1/5. And there you have it. That's example 9.